In this lesson, we're going to look at symmetric properties of functions, specifically whether functions are even or odd. So we're going to start with a definition. So f of x is, our first definition is that f of x is even if and only if, and actually all definitions in maths are if and only if something's defined. So if it's even, it has this property. If it has this property, it is even. So if f of x is even, if and only if f of minus x equals f of x. For all x in the domain of f of x. So it doesn't necessarily need to cover the whole real number plane as long as f of minus x equals f of x. Okay, so this means that this means the function is symmetric about the y-axis. And a couple examples of even functions are y equals x squared is symmetric about the y-axis, and it is an even function. Y equals the absolute value of x. Those are both even functions. Note, though, that not all parabolas and not all absolute value functions are even function. It has to be symmetric about the y-axis. So if you transform that function, move it left or right, it is no longer even. It has to be that f of minus x equals f of x. Okay? So, second definition, we have f of x is odd if and only if, so IFF is the abbreviation for if and only if, f of minus x equals minus f of x. Okay. For all x in the domain of f of x. And I'm going to take the opportunity here to show you a cute little symbol that we don't always write for all out. So we have this little upside down A that means for all. And that's a nice little abbreviation you might see as you head off into university math classes. Okay, so this means the function has rotational symmetry of 180 degrees about the origin. And so an example of that might be y equals x cubed, has rotational symmetry of 180 degrees about the origin. And if we take f of negative 3, so negative 3 cubed is negative 27, which is the same as negative 3 cubed. Similarly, y equals the cube root of x also has this rotational symmetry. Okay, so if we look at a couple of graphs, we can generally tell pretty quickly from looking at a graph if the function is odd or even. So let's say we have a nice little, whoops, that's not quite the right, as nice and even as I would like. Let's say we have a nice little Pac-Man ghost of a function. And it is symmetric about the y-axis. And then we have a nice little interesting absolute value looking function right there, and it goes kind of little lightning bolt looking. like that. And if we rotate one, it goes right on top of the other. So this one has that rotational symmetry, and this one has that reflective symmetry. So that would make the one on the left would be even, and the one on the right would be odd. Okay, and please do note, not all functions, most functions are neither even nor odd. This is not something, so domain and range, which we looked at in our last lesson, are something every function has to have a domain, every function has to have a range. Even or odd symmetry is something that's special to certain functions, but it's definitely not something that every single function has. Most functions do not. So you take a function like y equals x cubed, and you just add 1 to it. You translate it up 1 in the y direction. It's no longer odd. So just a little tiny change can keep a function from being either even or odd. Okay, let's look at a couple other functions. Okay, so let's look at a couple algebraically this time. So we have f of x equals cosine x, and f of x equals tan x. So tan x, let's try it. F of x equals cosine x, let's try it. So f of negative x equals cosine of negative x. So if we think about an angle, if we have an angle x, let's say it's acute, this is our angle x, and we think about what negative x is, negative x goes down like that, we notice that these two angles will have the same cosine. They will both have a positive cosine. So this is equal to cosine of negative x is going to be the same as cosine of x, because cosine is symmetric there. In quadrant 1 angle would be the same as quadrant 4, a quadrant 2 angle would be the same as quadrant 3. So f of minus x is equal to, so f of minus x equals cosine x, so f of minus x equals f of x. So we have shown that it has the property of being even. Okay? So here we have f of x equals tan x. So f of minus x equals tan of minus x. So if we look here at our angle x and minus x here for tangent, the tangent here is going to be, we'll have the same reference angle, so it's going to be the same number, but the tangent is going to be negative. Similarly, let's say x was in quadrant 2. Then this would have a, quadrant 2 would have a negative tangent, but quadrant 3 would have a positive quadrant. So f of negative x equals negative tan of x. It's always going to be the opposite if you take the negative angle. And so we get f of negative x equals negative f of x, showing that this function is, so the one on the left, we get f of negative x is equal to f of x. This is even. And here we have f of negative x equals negative f of x, meaning this one is odd. Okay. So let's see if we have yet one more function that's a little bit stranger. So f of x equals x plus 1 over x. Okay, so f of negative x equals negative x plus 1 over negative x. So this is equal to negative x plus 1 over x, which is equal to negative, sorry, this should say f of negative x is negative f of x. So this function here, because f of negative x is negative f of x, is odd. Okay. And so let's look at one more thing we could do with it. So if we have something where we have f of x equals x, we've got a piecewise function where x goes from 0 to 1, and then 1 from x greater than 1. So this function is defined like this. It goes up and then it goes over. This is at 1, comma 1. Okay, so what we want to do is they want to graph it. We want to extend the function over negative infinity to positive infinity so that it is even or odd. So if we take that sort of a half function and draw a full negative infinity to positive infinity function, that would be odd. For both of these cases, we're going to start with the same left-hand side. So we're going to start with our function the same way it looks up there. For the even function, we want it to be symmetric about the y-axis, so we're going to draw it symmetrically. For the odd function, we want it symmetric rotationally, so we rotate it 180 degrees, and then this also rotates, and it would be pointing in the opposite direction. Okay, and so those are even and odd functions. The most important thing to remember about even and odd functions is that most functions are neither even nor odd. It's a special characteristic of certain functions, but don't assume that everything is going to be even or odd.